Now it's time for a quadratic application that involves just a little more thinking to set up the function before we actually solve the problem. So the question in front of us is, it says 800 feet of chain link fence is to be used to construct 6 animal cages as shown in the figure below. You can see the external dimensions of the entire pen are labeled as X by Y. And you're asked some questions about one, expressing the length Y in terms of the length X, or rather width Y in terms of the length X, and then the total enclosed area of the cage in terms of X, and then a question about maximizing the enclosed area. Now, just as a reminder, it was back in chapter 2.4 where we discussed setting up functions, and that's where we learned how to write area, for example, in terms of a single variable. When I look at the pen, even though it looks like, you've got 3 lengths of chain fence that run along the border here of length X. I've got 3 of these guys at a standard height, okay? That's how they're sold at any of your home improvement stores. And the width is Y, so there are 4 pieces of fencing with a standard height whose width is Y. And then the external dimensions themselves are X by Y. So one thing I noticed just as I get my thinking cap on is that ultimately I want to express the area of the cages in terms of X. And I know that expressing area means area equals. And this will be the product of my external dimensions. That's the simplest way for us to calculate area, is to calculate the total enclosed area. The other thing I notice is that there are 4 standard height lengths of fence that are each of Y feet wide, and then 3 of them are X feet long, and that is supposed to total 800 linear feet of fence. Okay, so excuse me, I wrote that wrong, so this should be an X. Okay, so 4y plus 3x equals 800. Now you can take your pick, but since the question asked you to concentrate on writing everything in terms of x, that pretty much forces you to solve the constraint here for y. So I'd have 4y is 800 minus 3x. Dividing both sides by 4, I would have 800 minus 3x all divided by 4, or 200 minus 3/4 times x as y in terms of x. And so that would help me out because that satisfies what goes in my first box here. Okay, so I'm going to have y in terms of x. So this is going to be y equals 200 minus 3/4 x. Okay, now my part B is for the area, so I'm going to want area equals. Well, let's go back to where we were. If I put these two together here, area and my value for y, I can write the area as x times 200 minus 3/4 times x. Okay, and I can be satisfied with that for my second box here. Okay, in other words, if the calc pad pops up, you don't need to simplify. Now at some point you may have to simplify to answer the rest of the question, but if I were you, I'd get the parts that I could correct and check them without simplifying so that I didn't incur little bitty mistakes everywhere I went. Okay, so now we need to realize what kind of function we have. And we have area is a function of x, and if I distribute the x, I'd have 200x minus 3/4 x squared, which is also the same as minus 3/4 x squared plus 200x. Now I want you to think for a moment, how do I get from here to finding the vertex information of this formula? Okay, well, what we had said before when we derived this is when the input variable is analogous to negative b divided by twice a in that general form, so in this case negative 200 divided by twice negative 3/4, which gives us positive 200 all divided by 6/4, and you can take your battles here about how you simplify. That's the same as 200 times 4/6, which you could reduce at any point here. You have 800 over 6, and certainly so reducing, we'd have 400 thirds. But again, you know, you don't have to reduce unless the calc pad doesn't pop up, and I do believe in this particular problem the calc pad doesn't pop up. So the value of x in part C, when it says dimensions that maximize the total enclosed area, remember x was built into our formula as the length x. Okay, so we have identified that when x is 400 thirds, the area will reach a maximum. Now, you may or may not have been asked for the maximum area, but let's look at it anyway, because sometimes you will be. The maximum area is the calculation of substituting 400 thirds into the area function, for x. Okay, so if I needed the maximum area, this is it. 200 times 400 over 3 minus 3/4 times 400 thirds quantity squared. That's the maximum area. But now notice the question said find the dimensions. Now this is your area. The area is the total enclosed area. Okay, so you found the maximum area. But your two dimensions were x and y, and remember y was equivalent to 200 minus 3/4 x. So you could either take the maximum area and divide by the length x and get the other dimension, or you could just use the formula for our dimension. And we said again that y was 200 minus 3/4 x. And in this case, x was 400 thirds. Okay, if CalcPad popped up, we wouldn't have any trouble leaving y unsimplified. If you do some simplification, we can see that we have 200 minus, now notice here, quick cancellation, and 4 divides 400, leaving us with 100, and 200 minus 100 is 100. Okay. All right, now let's see if this actually works. Okay, let's check ourselves. All right, and again to recap, the area function is the one that's quadratic. It has an input of 400 thirds that produces a max area. This question didn't actually ask you to spell out the max area, but this is how you would do it if you had a question that did. Let's look at our dimensions. Okay, so let's go back here and let's think about what happened. Okay, we said that we had 3 guys of length x. Okay, so that's 3 times 400 thirds plus 4 guys of length y, so that's 4 times 100, and that had better check out and total 800, and indeed it does. Okay, so always do some mental math here to check yourself. Okay, so there you go.